Let's start out with the graph of f of x here, without knowing the equation of f of x, okay? But we have some points that lie on f of x. Now here's a question. If I'm going to have new function g of x, and it's obtained by reflecting f of x with respect to the x-axis here, how should g of x look like? How is it related to f of x? Well, graphically, the whole thing would turn upside down. This point would become down here, and this point would become here. Likewise, this point would go here, and this point will go here, etc. And the graph of g of x is going to look like this. And individually for the points, for the same x, as you can tell, the y for the f of x is going to have a negative in the front now, because it's upside down. From positive goes to negative, and from negative goes back to positive. So in general, if I'm reflecting a function with respect to the x-axis, so your y will become negative y. So basically you just add a negative in front of the whole function. So for this example, so f of x equals this. So we have to describe the transformation to go from f of x to become g of x. So just like last time, we have to rewrite g of x in terms of f of x. Then we'll see what else is added. So first of all, let's analyze f of x and g of x. If you look at the denominator, you see that one is exactly the negative of the other. However, it doesn't work if you see a different numerator, right? So it's not simply a negative of each other. So the trick is we may have to split this into two parts. So we start off with g of x, and this is where the trick kicks in. I add the 1 minus 1 here, which is actually 1 minus, in bracket, 1 minus x. So that it becomes two fractions now. Now I could compare this against our f of x, and it's just the negative of each other, and the second term is just 1. And so g of x actually equals to negative of f of x and then minus 1. And so to get g of x, f of x is first reflected with respect to x-axis and then translated downward by 1 unit. But you have to note that the reverse order is not the same, and for your information, it would be like that. Now let's come back to this, and this time we're asking, what is g of x? And how does it look like if it's obtained by reflecting f of x with respect to the y-axis? So if we look at the points individually, this point would go here, and this point goes here, and this one goes here, and this one goes here, etc. And so the graph will look like this. But algebraically, how is g of x related to f of x? Now if you look at the reflection points, you can see that for each pair, the y positions are exactly the same. It's just that for the individual points, all the x values have become negative, like this, okay? And so whenever we reflect a function with respect to y-axis, the x values will all become negative x. So check this out. F of x equals to this. So we're going to describe the way of transforming f of x to become g of x, if g of x is this. So for this one, there are some similarities. For the base 2, now I want to make 1 minus x to become somewhat x plus 1, and negative 4 to become plus 5. That's it. So we start off with the original g of x. Then I'm just rearranging the terms here, moving the negative x to the front. So we're already almost there, because when x becomes negative x, it's a reflection, right? And to completely match with f of x, I need a plus 5 here, right? So I do this here, which gives us this, and this is exactly f of negative x. And so f of x is first reflected with respect to the y-axis, that is the left-right reflection, and then finally at the end you minus 9, that is the translation downward by 9 units.